you have audio for this one? Yeah? There we go. Hey everybody, thanks very much for coming. It's my third session of the day, the final one, so I'm looking forward to a beer after this. So yeah, as I pimped out throughout the day, here's the visual effects graph talk. So a lot of these effects that we saw in the video just now, and the video we saw for the keynote, a lot of these have been made on the guy who sits about 5 yards behind me in the Brighton office where I am. So I've been pestering him for days and for weeks, some of these demos. And some of them are quite advanced, like we saw in the demo today in the keynote. And what I want to do is break down a few of the more simpler effects and show you how they're actually created and how you'd actually get started with a fresh visual effect graph and get going, yeah. So most of this is going to be in the editor itself. So live editor demos are always fun, right? So if you've not seen me already today, I don't know how you've missed me so far. I'm Josh Naylor. I'm an evangelist at Unity. And it's my job, much as John's, to travel the world and speak to Unity developers. So it's really awesome to be invited to Singapore. We've just done Developer Day Bangkok as well. And generally, I look after Europe, my team. So we go around to all the different European countries and Middle East and Africa sometimes to speak to Unity developers and show them new things. Now, Visual Effect Graph is one of the newest and most hyped things that's been around for some. That's in living memory, really, not living memory. But for a long time, I've been at Unity, and it's a thing that very much like shader graph. It appeals to so many people. It's not just like when you go to meet loads of programmers and they love ECS, or if you go to loads of artists and they're like, oh yeah, I love this new DCC tool. Like the visual effect graph and shader graph are tools that so many people can use that they've not previously had the ability to in programming before. So this is why it's so exciting for me. So yeah, I want to go over a quick overview first, and then later on we're going to show you how to make this effect. So what is the visual effect graph? As I explained in the keynote, this is what from our marketing team, a next generation visual effects tool for Unity. But what does that actually mean? So it's a programmable stack, so you can create your own nodes with the API. And what's really great, much like shader graph, is every asset that you create is a self-contained asset, very much like the post-processing, very much like shader graph, so that you can merge them across multiple projects, or if you make something really cool, then you can share it on the asset store, right? Rather than it just being a bit of code or like a self-contained effect like the particle system is that you have to export the full package, this is just one asset that you can pass around. And the reason why it is so great is because everything runs on the GPU and compute. So that's why right now it's just HDRP, not built in, and we're looking at ways to get it on lightweight render pipeline in the future. So yeah, as I said, it's artist friendly, it's scalable, and we've taken a lot of what other pieces of software do in the industry to kind of put this together. So a lot of the stuff that you can pass into it come from like Houdini and other stuff. And yeah, like I said, it's just the HD render pipeline right now. And the reason, like I say, it's so good is because it runs everything on the GPU. It can simulate really complex behavior. The Though one of the problems right now is that because it does run on the GPU, we don't have particles, which is a big thing. We don't have any access to the physics, really, apart from very, very primitive shapes, which, again, I'll show you soon. And there's no gameplay readback. So still, we're not sunsetting the particle system. It's still very, very useful for a lot of other things compared to what we're doing for the visual effect. So some general concepts. So it kind of comes in 3 layers. So we've got kind of like the asset creation, where we can, if we've never touched this before and we don't have really much of a concept of visual effects as a whole, we can still create things. This is supposed to be the base layer, where the majority of users are probably entering the visual effect graph and general VFX editing in general. So you can call events, edit parameters, you can pull out the noodles and see what kind of makes sense, which is what we're going to start with, just like pulling out some different attributes and parameters and seeing what we can create. After that is more actual VFX authoring, so people who have got a bit more experience, but still pretty easy to do. So author behaviors, set up interfaces between your existing features, such as like timeline or via code. And then there's more like general hardcore, like accessing the API and creating your own features and nodes on top of that, improving the library that we already have. So yeah, so just a bit more of an example of that. So the very base layer, you're going to launch a brand new VFX graph, and you might put in like a cat texture. All right, you're kind of getting used to the effect. So this is the general one, and then you just change the texture, and then straight away you can just create some very generic particles. After this is when you start to bring in a lot of complex math. Everything still is via nodes. So for example, you could take like the height map, or you could link in multiple effects on one graph. After that, you're creating your own effects. So if you're a VFX technical artist, or maybe a shader programmer, then you can kind of jump into that. So we wanted to make it accessible for all different people at different levels. Now I just want to explain a bit more about the flow of the graph. So as I said earlier on, we've got at the top spawn. So we're basically saying, how do we want our particles to spawn? Do we want it to be a periodic burst, a singular burst, a constant? How do we want it to be? And how many particles do we want to spawn at any one time? Then we have initialize, which is like the start function. Saying, oh, this is how many particles we want to save in memory. Do we want to set the color? How do we want to render it over lifetime? This is just a one-off thing, like a start function. Update, continuously updating the behavior of the particles as we go, and then the rendering output. So yeah, we have each of these is called a block, and then inside a block, we have context or context blocks. So each of these context blocks, it depends where they need to be. So you would not be able to get a periodic burst rate in the output block, for example. So they're all native to where they need to be in those blocks. Very context aware. And the whole rendering order, or the computational order, goes down. Then after that, we have nodes that we put into the context blocks. So we might have like some math functions, sine wave, multiply, a texture, just a general float. And we can either keep them as editable in the editor, the graph view, or we can expose them via the blackboard and parameters. So yeah, how many particles we want, what are their initial values, how do they behave over time, and how are they rendered. We can also, before spawn, we can add in effects like spawner effects or triggers and stuff like that. So like GPU events. And then we can also render out quad, point, line, mesh, multiple outputs. So here's an example of a bigger graph where we can make it very context aware. So we can add sticky notes and we can merge all the blocks together. Again, it's kind of like code commenting. And we can see here, which would actually generate shader code. We can see what would actually be on the CPU, and what would be like kind of crunched together. Oh, let's go back one. So we can see the bits that are actually sent to the GPU, the shader code. And that's the stuff that does all the rendering, the stuff that makes it possible to generate millions of textures and manipulate millions of textures, rather than with CPUs, we're still rendering on the particle system, we're still rendering on the CPU. So I want to jump into a live demo to visualize it a lot more. So I've got a blank scene here, and I want to go to Window, I want to go to Visual Effects and the Visual Effects Graph. And the very first thing I want to create, well, first of all, I need to select an asset or create an asset. In my hierarchy, I want to go on Create, and I want to create a Visual Effects game object. Now, this won't actually create the asset just yet. What it will do in my inspector is give me this visual effect component, and obviously it expects a visual effect asset. There's still a bit more cleaning up to do, so what will happen eventually is that they're going to add in a button here to say create new effect, like it says on the post-processing stack. Right now you have to go to your project, create, and you want to create a visual effect graph. So I've called this live demo logo, and then I'm going to put this into my effect here. Just going to change how my thing looks. Let's put it a bit darker. And here we have now in my game view, or in the scene view, a very standard look of what an empty new effect looks like. Let's click on it, open it up in the effect window. Very much like shader graph. So this is how it's built up. So this is just when I start a brand new effect. So we can see here, my constant spawn rate is 10. Let's turn that up to, say, 1,000. And you notice that nothing really changed too much. That's because in initialize, I've got my capacity is 32. That's saying I've created space in memory for 32 particles. And we can see, when we click on initialize, in the inspector, we can see the values it's created and how many bytes it stores for each attribute. So it's grabbed like color and alpha, speed, velocity, lifetime, such things. So again, let's change this to 10,000. Or 1,000 there. There we go. And I'm going to give you a quick warning to say this is a live demo in a beta thing. That's not a package yet, so if things go wrong, it's that team. I was actually pinging the guy at like 1 a.m. this morning because I couldn't figure out what was going wrong, and he was like, yeah, it's a bug, it's fixed now. It's because this build I have is 2 weeks old, and that's considered really old. So yeah, I've got in initialize, select velocity random between a min and max, set lifetime as random, again, min and max. This is just an empty thing. So if I want to create more of these, not doing anything in update, and all I'm doing is a quad output with a texture on, an orient, so I'm saying face the camera plane, but I could say, let's go along the velocity instead. So you can now see each particle is now rotating, and it gives you, with the sprite asset, where the velocity is going, and green is up. It's following along that. Set the size of a lifetime, and the color of a life. So very generic stuff that you would get in Unity anyway, say like the particle system. So maybe we want to swap this around. Start it big and go small. Cool. But that's not true. I want to do. That still doesn't look that nice. You won't want that in the game, right? So in create node, just right click anywhere in the darker area. Create node, and in system, we can see empty particle system, simple particle system. So this is a simple one. a static mesh one, or a simple swarm system, sorry. So if I click this one, again, this is just a generic template that we created to get people started. And what's great is that you'll be able to have your own templates in there as well. So when you go on Create Node, System, all of your templates of particles for your visual effect graph can be in there as well. So I just want to go through a few distinct differences between initialize, update, and quad output. So what we can do is, let's say we want to set the color. So if we did it initialize, we could either go through all of the different attributes like kill, position, or we can just search color. So I want to set the color. All right, and I just want to set this any color at all. So I'll set this to be purple, right? That's fine. So we're doing that once. That's good. What if we want to do that over time? So if I move this into update, but then I want to set, say, change that and do it to set color over time instead. Or set color from map, set color from. I could then say, let's set the color in here as well. So we'll start off as, say, red. And what we can do is, again, we've picked red best because we're setting it over time. We can, if it lets me, blend color. Live demos are always fun. Whoa. That's glitchy as. So what you could do is, so update's obviously doing it X amount of seconds, X amount of frames per second. And if I then wanted to move that to output, they do exactly the same. They would do exactly the same. But the reason why you might want to put one in update or one in output, because it depends how many outputs you actually have. So I could then create another output and create that, say, to be a cube output, for example. So now I'm generating quads, or I can generate cubes. Or I could convert output and change it to be decal or line or lit quad. All right. So that's not exactly what I want so far. Let's build up an actual useful system. So what I want to do first is I want to create a Unity logo out of particles. So first of all, I want to get rid of some stuff, such as, say, set color, set lifetime random, no velocity, and instead of constant spawn rate, I want to have one single burst. The next thing I want to do is I want to bring in a point cache, which is taken from, let's say, Houdini, and putting a point cache texture so that all of the textures will spawn on that. So I can go on here, and then I want a, let's create a node, point cache. This is looking for a point cache asset. Luckily, I have one pre-prepared. And when I pull that in, it tells me the point count has 425,000 particles. Right? And then in initialize, I've got my capacity. So I'm going to bring that to a similar number, say 55,000. And then I want to set position from map. So set position from map. And this needs now the attribute map from the point cache. I'm going to set this to sequential, and then I want set position, so we're setting all the particles position once. I want just a generic set lifetime. So that can last for, say, 6 seconds. Update, I don't want anything at all. And here I have a quad. I'm going to take this quad and change it to just be points. Do I want to orientate? No. Do I want to set lifetime over time? Nope. All I want is this. One more thing I want to do is, right now the position is local. I want to give the set position to be a world space and set it back to be my position in the world. My visual effect is on 0, 0, 0. So on this set position, I just want to pull out this noodle and click on operator, and it's now looking for a position. Attributes, which I've selected here, are things that's relevant to this game object. So I want get position on the get attribute, and that's basically like game object dot get transform. So it's getting the location, that's current position. And what we should see is this should work. Actually, I'm going to change this to be periodic. Oh, I know why. I did do that. Render order. Again, another thing that was a big issue. Here we go. That's a bug, which I was having at 2 a.m. this morning. So now we've got the Unity logo, which is made up of points. We've got 400 and nearly 500,000 points. We've got setting the position on the map with the point cache texture. We're setting the position. We're bringing into the local world. So we're saying, what is the current attribute? So what is the current game object position? 0, 0, 0. Setting that in the world. And we're setting a lifetime. We're not doing anything every frame. And then we're just rendering all of the points like so. Now, what if I wanted to... Let's move this around. So we could either change the rotation in the game object, or we can set the position like so. So I want to say transform position. I'm going to pull in this into here. And every single node, you can open it up even further. So now I want to change, say, the rotation. You could change the scale. We could change the angle. If it wants to work. It doesn't. It's a good job this is not in a package yet, right? Let's change that again. So let's just move it around the good old-fashioned way. Oh, that's upside down. Which way am I going here? Yes. Jeez. Thank you. I appreciate that. So we've got all of these particles, they're spawning, and it's a very simple, pretty simple graph, right? And what if I just want to comment it so that when my artist comes in, I can be like, oh, hey, I want to create a sticky note. Like, hello, This is the point cache. What if I now want to have something that moves the particles around as well? So in update, we've got this thing called turbulence, and it's just a type of force. So now, because everything is a point in the world, I'm just continuously manipulating those particles with this turbulence texture, which is kind of like a noise texture. Let's zoom in. Let's see what we can change as well. So we could change things like the position, the angle, the scale, the intensity, which is exactly what I want to do. I want to expose that intensity to my inspector so that I could fiddle around with it in the inspector and the hierarchy. And then I want to expose that to timeline. So I'm going to grab intensity here. And because I'm going backwards instead of forwards, it tells me everything that can go into that. So we can say an attribute, bitwise color, logic, all sorts of stuff. I just want just a float. So now I can change this float this way. And now it's just available for me to. But I want to actually put everything on my blackboard, which is used to change everything and a parameter, kind of like when you're creating a mechanism animation and you want a trigger or a bool. So, yep, convert to parameter. And it's called new float. Open up my blackboard. And I want to change this to be called turbulence intensity. And I want to make this exposed. Now, if I go to my visual effect graph, I can see that I have this parameter, turbulence intensity. I don't even know if that's spelled right. And I can change this to be whatever I want. What if I wanted to change the color over time? What if I wanted to change this variable over time? Let's do something similar. So I could either set my color initially in initialize, I could set it over time in update, or I could just set it into my point output. So I'm just going to set it in point output. So I'm going to create a block, say set color. Change it to be, say, yellow. Again, I want to create a color. And I want to expose this, convert to parameter, color, and expose. So now in Visual Effects, I should see new color. So again, I can change everything just via the inspector. Cool. So let's create a timeline. Let's open up timeline here. Let's create a new timeline, visual effect timeline. It's going to replace one of my old ones. Now it's here. I can click on visual effect timeline. Let's lock it in place. Press record. And on the very first frame, I want it to be yellow. And let's go a bit further and then change that to be pink. And then maybe halfway through, we'll change the turbulence intensity to be -5. And then we'll turn it back to be 5. Let's go to the beginning and change that to be 5. Stop recording and then press play. So let's go to our timeline. Let's go and play awake, wrap mode, loop. Now, let's press play. And it's going to run through that timeline, play the effect, change the color, change the intensity, all in one. Pretty nice, right? I mean, but how useful is this in your games? Maybe not much. Maybe it's your splash screen. Like every game that I make now, every game jam game, I'm going to make the most amazing splash screen. It's going to be a terrible game. I'm going to spend about 5 minutes on the game, but I'm going to have the best splash screen. So let's create something that may be useful in your game. This one is just what I want to guide you through. So one of our artist interns who's been playing with this and released a video on the YouTube channel about the visual effect graph, he made this, so I can't take all the credit. I just like making pretty stuff like that, and he actually makes useful stuff. So, oh, let's save my scene, live demo. So this demo here is, let's press play and see, is a snow system flying through the city, or it was when it didn't do that. So what's happening here, apart from the weird glitchy stuff, is that he's got this snowstorm following this camera system around. So he's got a Cinemachine camera system flying around. It's got the camera just on this dolly track. But it's got this crazy snowstorm happening at the same time. And this snowstorm is not covering the entire scene. It's just following a volume around the camera. So let's see what it's doing here. When I go on scene, if I click on the, which one is it? VFX weather storm, we can see, where is it? Chasing it around. The track here, and we can see this white volume. This is the volume that the particle system is all, not the particle system, the visual effects graph system is all part of. And we can see all of those specks spawning around it. So let's open up the graph and see. This is how I managed to squeeze it into one screenshot. So we can see we've got a constant spawn rate, very standard, and it's got a spawn rate exposed in the editor. In initialize, this time we've added the bounds, and we've taken the main camera as a parameter and put it into the bounds. So every time a new particle spawns or initializes, it will spawn from the center of our main camera. This is just like saying camera.getMainCamera. We're getting some random velocity, and then we're applying a volume where everything initializes from. In this case, we've got a box size, and because we've already set up here where it all spawns at the center of the main camera, we're saying this is a huge volume, 10 by 10 by 10, spawn on the main camera. And that's what we could see, that white box. We're setting a lifetime, random. We have some turbulence, but then also we've used, well, not we, he, not me, because I didn't create it. It's got this force node. And in here, he's taking delta time, just total time, some wind direction, making this an exposed vector-free variable, passing this in a sample curve, adding some wind strength, and then multiplying all together to pass into this force. Which means when we go to our inspector, let's make this a little bit bigger and go to our weather storm system. We've got spawn rate, so we can make it really thick snow. Our box size around the camera, what kind of wind strength do we want, and where is the wind direction coming from? All of this is just through exposed parameters. Again, this is now accessible via code. It's accessible via timeline for us to play with. And again, accessible for people who don't know what they're doing, and they can just play around with these sliders rather than the full effect graph. Let's turn that down a bit. I mean, this is the only type of snow you're going to get in Singapore, right? Nice. So one last effect that I want to show you, because I've got 10 minutes left. That big, crazy Unity spinning logo thing before. Again, an amazing splash screen, just not a good game. So let's create a new scene. Do I want to save the scene? No. Let's create a new Actually, I'm going to go back to, I've got not much time, so let's go to my effects. So yeah, I want to create this, right? Another amazing splash screen. I'm going to swap out my logo to this one. And this will be nothing right now because I've taken all the nodes off. And I want to show you how to build this up. So initially, we've got an initial color scrolling. So we're taking periodic total time with this sample curve, just with some nice colors. We're multiplying this by a magic number, 6. Why not? And we're passing this in to, say, set color. Cool. Nothing's happening, of course. I want a constant spawn rate, 240,000 pixels, and have like 1.5 million pixels. Ready? I want to spawn everything, not from a box this time, but from a sphere. So I want to add in a position sphere. It's a volume and make everything spawn randomized. That's fine for now. And then I want to add in some sphere motion. So you see when the particles spin around that it's all spawning from different areas. This is all just some nice heavy math. Everyone loves math, right? So we've got total time per particle, we've got a sphere position, the initial sphere position. We're multiplying this by one sine and one cosine wave. We're vectorizing this, multiplying this by the amplitude, by how quick it's actually moving. Putting this into a sphere component, setting the sphere radius. And then we're going to pass this entire thing into our sphere position. So we're going to grab the center and put it into sphere here, or maybe the other way around. Lovely stuff. Again, nothing is still happening. That is fine, honestly. We've got things like a sphere collider, so we can see that hits other particles in the space. We've got force. We've also got things called vector fields, vector force fields. So we've got some assets, again, taken from Houdini, so inner particles, so they make the particles all hit each other. And then we've got another Unity logo where all of the particles will spawn towards. And then a quad output. So, how does this work? Let me tell you. Again, we'll take our size of a velocity, pass it into set size. We want to take our color blending, pass it in here, and then we want to activate along velocity. Again, this took so long to set up that I cannot remember the exact order. Yes. So, what are we looking at? We're looking at a sphere where it's moving around along a cosine and a sine wave, moving around the scene, and it's spawning from its volume like 140,000 particles. Each with a lifetime between 3 and 4, and it's just got this set color wave, initial color scrolling. Next up, we want to add, and we can see when we're using update that every particle here is being taken back into this vector field, the Unity logo. I want to add in a bit more. So I want to add in another vector force field, which, whilst, yes, they're all going to the Unity logo, they're also getting pushed out a bit as well. So they don't just like fly in instantly. Let me just show you as well, when I turn that off and turn the intensity up, we can see how quick the particles gather to the Unity logo vector field. So I just want to turn that to be 1 again, so they don't do it so quickly. Turn up this vector field and change the intensity a bit more. So again, they do it a bit more slowly. And then in update, I want to have a sphere collider. So there's just going to be a collider as a sphere, and it's just going to hit the particles. And when it hits them, they'll obviously be affected by that force. Right now, that sphere collider is not doing anything, or it's just in the middle of the screen. So I want to attach it to what I made previously, my flying sphere. So I want to go grab sphere and then pull it back into all of my other math function. So we can see now, as that sphere goes around and hits the other particles, they're colliding with it. So when we look at the graph from the outset, it does look very complicated. But when we step through it and see and build it up as we would do as we're making it, and we understand what we actually need to demo something like this, we can see that it comes quite easily. And what we've done here, again, like with the sticky notes, you can grab multiple nodes, right-click, and then group selection, like so. The benefit of these is we can grab multiple nodes. So say if I wanted this exact same math function, I could copy that and then paste it into another graph. Right now, we can't have multiple graphs open at the same time like we can with shader graph, but so that's in the roadmap. Because right now, I'm looking at John's laptop with a screenshot of the graph I created earlier on, because I can't open two at the same time. Cool. So a bit further down the road, what are we hoping to do with this? It's going to be available as a package manager very, very soon. Shader graph integration. Subgraphs, very much like shader graph. Some CPU particles so that we can bind physics properties onto the graph. Trails. And I thought there was one more, but there's not. Thanks so much for listening today. I'm available around for questions for the rest of the day, but thanks so much for having me at Unite, and hope you found this session useful. Thank you. And I'll just be outside for questions, because I want to allow the next speaker to set up. But yeah, thanks very much, guys.